Hello and welcome back, everyone. In today's video, we're going to talk about how Google understands infrastructure, how Google indicates physical infrastructure. When people think about Google, they often think about search results or maps, but for infrastructure owners, Google functions as a global indexing system for physical assets. So what does that mean? Google does not see infrastructure the way that humans do. It understands infrastructure through structured signals. That's coordinates, imagery, metadata, and contextual references across multiple platforms. Roads, bridges, airports, utilities, and public spaces are indicated not just as locations, but as data objects that are continuously updated, verified, and cross-referenced. So understanding how this indexing works is foundational to modern infrastructure documentation and digital visibility. Now let's talk about why infrastructure visibility matters to cities. For cities and public agencies, infrastructure visibility is no longer optional. Digital visibility affects planning, funding, public trust, and operational decision-making. When infrastructure is accurately represented across mapping platforms, agencies can gain clearer situational awareness, stronger documentation, and better align with external stakeholders. Conversely, if infrastructure is poorly represented or digitally outdated, it becomes harder to maintain, harder to manage, harder to justify in budgets, and harder to define and defend during audits or reviews. So visibility directly supports accountability, transparency, and long-term asset stewardship. Moving on to roads, assets, coordinations, and metadata. From Google's perspective, infrastructure is not a single object. It is a combination of different elements. A road is defined as coordinates. An asset is defined by locations and attributes. Metadata provides context. So that context is what the asset is, when it's being observed, and how it relates to its surroundings. This includes identifiers such as geographic coordinates, timestamps, descriptive tags, and relational data that connects one asset to another. So together, these elements form the digital identity of physical infrastructure. So now, where are these agencies interacting with this data? Agencies interact with this infrastructure data across multiple environments. Public-facing platforms such as Google Maps influences how infrastructure is perceived externally. Internally, GIS systems, asset registers, and planning tools rely on spatial accuracy data for operations and budgeting. Increasingly, AI systems and search tools reinforce the same underlying signals when generating summaries, insights, and recommendations. So, consistency across these systems is crucial for maintaining data integrity. Now, there are some risks with poor digital representation. When infrastructure is poorly documented digitally, several risks emerge. Assets may appear outdated, incomplete, or inaccurately located. Visual records may lack context or verification. Data inconsistencies can undermine confidence during your audits, grant applications, or procurement reviews. And over time, these gaps compound, increasing operational risk and reducing an agency's ability to make informed decisions. Digital misalignment becomes a hidden liability. So now, how does GATT align infrastructure with digital systems? At Grace Aerial Technologies, infrastructure documentation is approached as a systems problem, not as a media exercise. We focus on capturing infrastructure in a way that aligns imagery, coordinates, metadata, and spatial context from the start. Our outputs are designed to integrate cleanly with mapping platforms, GIS environments, and internal agency systems. By maintaining consistency across visual, spatial, and technical layers, GATT supports accurate digital representation that strengthens visibility, trust, and long-term infrastructure management. And in closing, the foundational understanding of how infrastructure is indicated digitally sets the stage for more effective asset inventories, mapping, and data-driven decision-making. Grace Aerial Technologies turns observed environments into usable mobility data.